Welcome to Chapter 8 C++ Labs 8, 1 and 8, 2, Swapping Values and Bubble Sort. Please like, subscribe and hit the notification bell. If you are prompt to create a YouTube account, it is free and only takes less than a minute. When you subscribe, you will be notified when new videos are posted, and it make it easier to navigate and find videos on YouTube. Let's look at our tasks. In this lab, you will complete a C++ program that swaps values stored in 3 int variables and determines maximum and minimum values. The C++ file provided for this lab contains the necessary variable initializations, as well as the input and output statements. You want to end up with the smallest value stored in the variable named first, and the largest value stored in the variable named third. You need to write statements that compare the values and swap them, if appropriate. Comments included in the code tell you where to write your statements. Write the statements that test the first 2 integers and swap them, if necessary. Write the statements that test the second and third integer and swap them, if necessary. Write the statements that test the first and second integers again and swap them, if necessary. Task 1. Execute the program using the following sets of input values: 101, 22, 23, 630, 1500, 921, 22. When you input those numbers, the display should be enter first number, 101, enter second number, 22, enter third number, -23, smallest, -23, next largest, 22 largest, 101. Let's take a look at the code. The first thing we notice is the 4 variables declared and initiated. Looking at the rest of the code, we see where our comments have been added to show us what we need to do. Let's get started. Let's go to line 26. Here is where we will test to see if the first number is greater than the second number. Type if first is greater than second. Don't forget your semicolon. Insert brackets. Then, on line 29, second equals first, then on 30 first equals temp. Now let's go to line 33. This is where we will test to see if the second number is greater than the third number. Type if second is greater than third, enter, and add brackets. Go to line 35 and temp equals third. Then third equals second, enter second equals temp. Next, we will print numbers in numerical order. On line 49, type console out smallest, first then end line. On 50, console out next smallest, second, then end line. And on 50, type largest, third, then end line. Now let's take a good look at our code. Make sure there are no errors. Check your syntax and punctuation. Everything looks good. Let's run the program. Our output displayed correctly. You can input the numbers if you like. With the calculation, it shows 100% with the green check. Let's take another look at the code. You can pause if you need to. This video is going to cover using a bubble sort. Suppose we have a list of household sizes and need to arrange them in ascending order. Household sizes 4, 2, 5, 1, 3. Using the bubble sort algorithm, we would compare adjacent household sizes and swap them if the left element is larger than the right element. This comparison and potential swapping would continue until all household sizes are in ascending order. The final sorted list would look like this. Sorted household sizes 1, 2, 3, 4, 5, 4. Let's look at our task. In this lab, you will complete a C++ program that uses an array to store data for the village of Marengo. The program is described in Chapter 8, Exercise 5. The program should allow the user to enter each household size and determine the mean and median household size in Marengo. The program should output the mean and median household size in Marengo. The file provided for this lab contains the necessary variable initializations and input statements. You need to write the code that sorts the household sizes in ascending order using a bubble sort and then prints the mean and median household size in Marengo. Comments in the code tell you where to write your statements. Task 1. Write the bubble sort and output the mean and median household size in Marengo. An example of the program is shown below. While the inner loop will compare adjacent elements and swap them if they are in the wrong order. This ensures that the largest unsorted element bubbles up to its correct position. Enter household size or 999 to quit. 4. Enter household size or 999 to quit. 1. Enter household size or 999 to quit. 2. Enter household size or 999 to quit. 4. Enter household size or 999 to quit. 3. Enter household size or 999 to quit. 3. Enter household size or 999 to quit. 2, and so on. Let's take a look at our code. We see there are 11 variables declared and initialized. The comments show a few functions and what they do. At the bottom of the program shows the output to be printed out. Let's start on line 43. Type limit equals sign x, then place your semicolon. On line 45, we will find the mean by typing mean equals sum divided by limit. Don't forget your semicolon. The work done in the sort array function will start on line 47, x equals 0, enter. On line 48, pairs to compare equals limit minus 1. On line 49, switch occurred equals true. On line 51, we will start with the while loop. While x is less than pairs to compare equals true. Let's insert our brackets on line 52. Then on 53, x equals 0. Make sure you insert the correct number of brackets in this loop. This may be a good time to pause the video to complete lines 56 to 65. To reduce the number of pairs, go to line 66 and type pairs to compare. Make sure you have the correct number of brackets. Mean. The mean is simply the average of all the household sizes. It gives us an overall idea of the typical household size in our dataset. We can calculate it by summing up all the values and then dividing by the total number of households. This process ensures that we account for every household in our dataset. Median. The median is the middle value when the data is arranged in order. It represents the point at which half the households have sizes smaller and half have sizes larger. Let print the mean by going to line 70 and console out mean household size in Marengo is, don't forget to space and add the colon. To find the median, go to line 72 and type median equals limit minus 1 in parenthesis divided by 2. Now we need to go to line 74 to print the median. Type console out median household size in Marengo is leave a space, then a colon. Then household sizes with median in the array braces, then end line. That should all we need for our code. Let's check the code for errors. Make sure all the punctuation and spelling and spacing is correct. Everything looks good with the code. Let's go ahead and run it. We achieved the desired outcome. You can go ahead and input the numbers to test your output to see if it matches. Now let's see if it calculates to 100%. It does. Section 10. Mastering C++. The importance of swapping and sorting. Mastering swapping values and sorting algorithms like bubble sort is crucial for any C++ programmer. These concepts are not just academic exercises, they are fundamental building blocks used in countless applications. If you find this video useful, please hit the like button, leave a comment, and subscribe to the channel. To see more videos like this, please click in the rectangle in the middle of your screen. To see other videos from this channel, please click the circle on the bottom right. This knowledge will prove invaluable as you progress to more advanced C++ programming concepts and tackle real-world problem solving.